Alright guys, we're going to take a look here with a little bit of an intro to limits. So not quite chapter 2, but we're going to start to give you a little background. So the first thing we need to remember is that calculus has two goals. Alright, the first one, can you find the slope of a curve? Alright, that's our first goal. So you want to find the slope basically by saying, can you find the tangent line to that curve? Right, so something to keep in mind. Can we find a tangent line? Remember, a tangent line is a point that crosses a line at one spot. So there's an example of a tangent line. Okay, so as you can see, my tangent line is crossing my curve at one point. Alright, can you find the tangent line of that curve? You betcha. Right, there's a tangent line of that curve. Calculus has two goals again. Can you find the area of a curve between 2 points? So here's my curve right here, right? We'll just say point 1, we'll call it A, and point 2, we'll call it B. Could we find the entire area underneath there? So the explanation of our first goal, the tangent problem. All right, this is the very first whole half of calculus. If I find the slope and I find a random point on the curve somewhere else, I could then make an equation, right? We know how a linear line works because basically a tangent line is a linear line. So if I can find the slope and I can find a random point, I basically could find the equation of the line, right? Y equals mx plus b. Basically what we're saying. So here's the problem. To make a line we need 2 points and we only currently have one, right? It's where it's tangent. We have 1 point. So there's our 1 point. So how do I make a line with only 1 point? Now that's the whole issue here with calculus. So I'm looking to see how I can possibly find that tangent line. I don't know the slope and I only have 1 point. Alright, how is that going to work? So let's plot another point Q. So here's P and here's Q. So if I was to take P and Q, right, here they are. If I was to take P and Q and create a secant line instead of a tangent line. Remember, a secant will then cross through 2 points. So a line from P to Q would be a secant line. So there we go. A P to Q, a secant line is created. Okay? But that's obviously not a tangent line. Okay? That goes between 2 points. A tangent line crosses at 1 point. So how accurate is that actual line of the curve? So the answer is, can we get a better approximation? Yes. Here's how you're going to get a better approximation. We can move point P down the line closer and closer. So the point is, it was here. I just slid it down here. So we're getting a more accurate gist of what that tangent would be. First of all, it went like this, right? Straight through, just like that. I moved Q down. Now my line's going like this. I'm going to try to continue to slide Q closer and closer to point P to create that tangent line. Okay? Because remember, in order to create an actual equation of a line, I need the slope. I need 2 points to find that slope. And then I need a point to plug in. We can actually move that point so close, so really, really close to P that it's practically touching the point. That's the key. Okay, so super, super, super close. But not so close that it's the same point. Because if it is the same point, I no longer have 2 points. They need to be 2 different points, but so, so close. Alright, so, so close. So we need 2 different points in order to make a line. We remember this back from algebra. So, as Q approaches P, the secant becomes a more approximation of the tangent line. So, here's where Q was. As Q approaches P, right, so the secant line, the original secant line, becomes a better approximation the closer we get to what the tangent line would be, right? Q is here, now it's here, now it's here. That actual line becomes a better approximation of what our tangent line could be at that point. So things to keep in mind. 2 points can get infinitely close together because you can always take the midpoint of 2 points to get something smaller or something in between. So The point is that you have 2 points. If you're finding the midpoint over and over again, there's always a middle between 2 points. All right? The middle between 1 and 3 is 2. Then the middle between 1 and 2 is just continue down the line. You're always going to have something that's between there. All right, when you add 2 points and divide by 2. So basically, calculus says we can get Q so close to P that there is no difference between the secant and the tangent line, that they are basically the same. So we could have a point at 1 and a point at 1.0000000000001. They're not the same point, but they're 2 points that are so very close to each other that I could then find the slope of those 2 points and use that to find the actual tangent line. And using calculus, it means moving something really, really, really close to a point but never touching that. That's called a limit. That's the very first thing we are going to talk about. Actually moving something so close but it never touches it. Right? That's a limit. And we'll be really hammering that home here in Chapter 2. So our first example, find an equation of a tangent line to y equals x squared at the point 1, 1. So what does that mean? It means, here's a rough graph of that. Here is our graph of y equals x squared. Now granted, it should also go over here, but I stopped it because I only need it at the point 1, 1, so I'm only showing you the 1/2. Alright, so find the equation of a tangent line at that point. So a tangent line would go right smack dab through that point. I want to find out that tangent line that would go through that point. So here's what we're going to do. I'm going to plot a point Q at xy. I have no idea where that point is. I'm just going to put it up here. I have absolutely no idea what x and y are, but x is this direction, y is this direction. I just placed it up here, but it doesn't matter where point Q is. We don't know what that is yet. Since y equals x squared, right? If I plug in x, remember, that's y. We just said if you look backwards, that's x and that's y, right? Well, we know y equals x squared, so instead of xy, it's, by substitution, x squared. Okay? Remember, xy, if y equals x squared, I plugged it right in there. So here's why that is so helpful. Since we can find the secant line, and we know how to do that, at the random point Q, as it gets really, really close to P, it will be an approximation of the tangent line. So currently we're trying to find an approximation of what we think the tangent line would be. So that's what we know so far. And we got to find the equation of a tangent line. We're going to use our point slope formula. That's y minus y1, the slope of the tangent line times x minus x1. So we use the point slope form. We have it right here. Okay. All right, and we find the tangent line. Just have to figure out what that slope is. In order for this to happen, we need to find the slope. So let's do that first. I know point 1, right? P1. That's the point I have. X1, Y1. I know what those are. So I can plug in my X1 and my Y1. I also actually know Q. Q is my second point, right? And we know that that's x and that's x squared. So when we plug this in, x2 is right here, y2 is right here. So basically I'm just doing substitution to find that slope first. So we're going to find the secant line to get a better approximation. So to find the slope of the secant, y2 is x squared minus y1 is 1. So you get x squared minus 1 over x minus 1. Alright, now think about this a little better. Look at this right here. I hope we notice something about that. Remember, as we said, Q approaches P. We write that just like this so you understand. As Q approaches P, okay, the slope of the secant approaches the slope of the tangent. So the slope of the secant becomes the slope of the tangent. It gets closer to it. Now, we cannot have 1 because if you remember, if I plug a 1 in on the bottom, right, I'll end up with a 0 in the denominator. Can't have a 0 in the denominator, right? If I plug it in here, I'm actually going to get 0 over 0. All right, can't have 0 in the denominator. So we know that I can't have a 1 in the problem. Something to keep in mind. We'll hit back on that a little later. So let's try to factor. All right, we're going to try to factor. Why? Because we can't plug in a 1 and we can't get an answer to the problem. All right, so I can substitute 1 into this problem. All right, but what you'll notice is if we factor and try to simplify this, the top I can factor, right? X squared minus 1 gives me x minus 1 and x plus 1. So if I factor that out and I plug that into the top like so, notice what they both have on top and bottom. I can cancel those out, leave me with x plus 1. That you can actually plug a 1 in for. So our secant, all right, instead of getting an actual number, because I don't know an actual slope, okay, I just know approximation, and we were only given an equation. So the slope of my secant is x plus 1. It's not an exact number yet. So what happens as x approaches 1? We do substitution to see where it goes and what it gets close to. So if x equals 4, right, the secant, right, equals, if x equals 2, right, we're trying to figure out what it equals. If I plug in a 2, 2 plus 1 equals 3. If I plug in a 1.5, I get 1.5 plus 1 equals 2.5. Right? I'm just trying to show you. So if we go back here, if x equals 4 and I plug it in, 4 plus 1 is 5, right? There we go. If I plug in a 2, 2 plus 1 is 3, right? I'm just showing you what happens as it gets close to 1. If I plug in 1.5, 1.5 plus 1 is 2.5. If I plug in 1.1, right, I'm just getting really close to 1, I get 2.1. If I plug in 1.01, 1.01 plus 1 is 2.01. What does it look like I'm getting closer to? Right? Right up here. 5, 3, 2.5, 2.1, 2.01, right? 2.00001. What am I getting really close to? As my x gets really stinking close to 1, right? That's really close to 1. What's happening? It's approaching 2. So what happens as x approaches 1? As x approaches 1, the secant approaches 2. So if I could let x equal 1, the tangent would be 2. If I could, it would be 2. The slope would be 2 if I could. So we go back to the beginning. I now know my point. My random point is 1, 1. I now am guessing that my tangent is 2. So we do substitution to plug everything in. Right? Got a 1 in there, a 1 in there. My tangent guess is 2. So we distribute to get 2x minus 2 minus 1. I add 1 over, and that would be our guess of what the tangent line would be. Y equals 2x minus 1. And if you were to take a look, if that's the point, and you were to take a look at me drawing the tangent line, does it not look really, really close to 2x minus 1? Yeah. Minus 1 up to over 1. Looks really darn close to 2x minus 1. When we come back, we'll take a look at the part 2 of calculus, the area problem.